Our lesson for today is about absolute value inequalities. So you've done regular compound inequalities and you've done regular absolute value equations. This is actually going to be a combination in both of them. So a few things that are important. If you have the absolute value of some sort of expression is greater than, or if you have that it's greater than or equal to, this is going to give you what we call an OR inequality, which means that when you graph it, you're going to have two things going in opposite directions. And for the top one, it's going to look the way that I have it here. For the bottom, it'll be the same thing, but with these two things filled in. So that's an OR one. Those are the ones where you have something or something else. I'll do an example in just a minute just to clarify that. The other type that you're going to get is if you have absolute value of something is less than, or absolute value of something is less than or equal to. This is what we call an AND inequality. The AND inequality is going to be one of the ones where you are shading something in between. And those are the ones where you have a number is less than or equal to an x value, and then less than or equal to another number. So those are the two types that we have. If it doesn't make a lot of sense now, that's okay. I'm going to go through some examples. And for these examples, we are going to solve and graph. So my first one is the absolute value of 3x minus 7 is greater than or equal to 5. So you might be able to tell right away by looking at the top part of this slide that this is going to be an OR, which is a good thing to know. The next thing that we need to do is we have to split this up into two. So the first one, you are just going to rewrite this whole entire thing but without the absolute value bars. The second one, you keep the 3x minus 7 as it is. The sign is going to switch around, and the 5 is going to become negative. So for that part, the two things that change are this sign and this sign. So just make sure you know what you're changing around. So then, from there, we are going to solve each of these. You solve it like you would solve a normal equation or inequality. There's nothing extra special there. And I always need to make sure to put the OR in the middle, so don't forget to do that. So when I add 7 to both sides, and that gives me 3x is less than or equal to 2. Unfortunately, I divide both sides by 3, and I do get a fraction. That's okay, though. We are still going to be able to graph it. So then this is my final answer down here. X is greater than or equal to 4, or x is less than or equal to 2/3. So I'm going to go ahead and graph starting at 0 and ending at 4. So first of all, I have x is greater than or equal to 4. We know that this is going to be closed because it's greater than or equal to, not just greater than. We also know it's going to go to the right because of two things. First of all, because it's greater than or equal to 4. The second thing is that we know it's an OR one, so it's going to look just like our top graph up there. The next one, we have less than or equal to 2/3. I don't know exactly where that is on the graph, but I know it's going to be more than 0, less than 1/2, and less than 1. And so it's closer to 1 than it is to 0, so I'm going to kind of do it right there. And then that's going to go to the left. Also, this is going to be also a closed circle. So for this problem, if you feel like you're good enough to do it on your own, go ahead, pause right now. So our first step is to split this up. And we know that this is going to be an OR because it's a greater than. So we are going to start by writing this out as 4x plus 5 is greater than 13. Just leave it the exact way it's written, except without the bars. Also, 4x plus 5 is less than negative 13. So for the first one, I just solve this as normal. I end up getting x is greater than 8. The second one, I do the same thing. And I end up getting x is less than, when I reduce this, I get negative 9 over 2. So the graphing of these ones is always a little bit tough. So 9.9 over 2 is actually the same thing as negative 4.5 or negative 4.5. So it's a little bit easier if you change your improper fractions to a mixed number. So I know that that's going to be somewhere between negative 4 and negative 5. Unfortunately, I have a huge range of values. I have 8 as my highest one, my lowest is negative 4.5. So rather than just going by 1, 2, 3, 4, all the way up to 8, I can actually go by 2s, or I can even go by 4s if I want to. So I'm going to put 0 in the middle, or kind of near the middle, and then just go by 2s. And so my graph for both is going to be an open circle. And for the 8, it goes to the right. For the negative 4.5, it's going to go to the left. And that's my final answer. So next one I have is x plus 5 is less than 2. This one you might notice is an and one. I'll show you how to do this one. So it's a little bit more complicated at the end part. So we're going to first start by splitting this. We have x plus 5 is less than 3, and x plus 5 is greater than negative 3. Remember, you change both to a negative 3 and you flip the sign around. From there, you just solve it like you would normally solve one of these. You get x is less than negative 2, and x is greater than negative 8. The complicated part comes here, where we need to combine this into one inequality. So you're going to do that by writing the numbers in order. So my lowest number here is negative 8. My highest is negative 2. The x is going to go in the middle. So then if you think about it, you might notice that this x is less than negative 2. We have the open larger part of the inequality towards the negative 2, and it's pointed towards the x. So we're going to keep it that way. And actually the one with the negative 8 is always going to go in the same direction. So with these types of problems, the two signs always point in the same direction. So this is what an inequality looks like. And that's my answer for that. Now I just need to graph. And I'm going to actually go by 2s again, put 0 all the way over there, negative 2, negative 4, negative 6, and negative 8. So now I need to graph this one. Remember that this type of inequality, oops, I made a mistake. So this type of inequality is going to be shaded in between the negative 8 and the negative 2. So then I'm going to make it look like that. So for the last one, if you're feeling pretty good and confident about these, go ahead, pause, try it on your own, see if you can graph it, and then you can fast forward all the way to the end. If not, I'll go over it. So first thing for this one, I am going to rewrite this as h plus 4 is less than or equal to 4. This one's an and, by the way. And h plus 4 is greater than or equal to negative 4. So I'm just going to solve this out like normal. I get h is less than or equal to 0. And I'm also going to get h is greater than or equal to negative 8. So as with the previous one, we put our lowest number first, we put our variable, we put our highest number. Now we look back at the higher number. I have h is greater than, or is less than or equal to 0, so I'm going to keep it like that. And I'm going to put the other inequality sign in the same direction. This is my answer for that. So now I'm going to draw my picture. Going by twos again. If you don't want to go by twos, you don't have to, but it might be easier sometimes. So then I am going to have a closed circle at -8 and a closed circle at 0, and then I'm going to shade everything in between those two values. And that's my answer.